Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience. Hi everyone, today we have with us Thomas Swift, who is a lecturer in polymer chemistry at the University of Bradford. Hi Thomas, how are you doing?
Hi, I'm doing really well, thank you. How are you?
Good. Excited to understand more of your research. So let's start with understanding your career journey, your scientific journey so far. So how did you end up in your current research field?
Unintentionally, but loving every second of it. I ended up doing a degree in chemistry. I did a master's in chemistry at the University of York, mainly because I liked science. I didn't like maths and I didn't like flowers. So I ended up doing chemistry, and I ended up doing a master's. And I thought at the time I was done with university, I'd loved it. I'd found it difficult, but I'd really enjoyed my time at university. But as part of their sort of, they put people onto you, and that meant that my first job when I left York, I was already working for the R&D arm of an international paint manufacturer. I spent over a year of my life working on self-cleaning paint. Which I really loved the job. I loved everything about it, apart from going out and meeting people and they say, well, what do you do for a living? And when the answer is honestly, I watch paint dry and then study it after it's dry. Yeah, that was the only killer. But I loved the job and I would have stayed there, but I was looking around at career progression within the company and I realized more senior managers in the company had a PhD than didn't. It's not a given that you get a PhD and you get promoted, but I was looking at my options and I thought maybe there's a point, maybe I should go back and get that extra qualification. So I briefly stepped out of chemistry in academia into industry, and then stepped back without having planned to. The PhD I managed to get my way onto was an industrially sponsored one. So this was paid for by a flocculant manufacturer. Flocculants are the chemicals which let's say you've got reservoir water and that the water that's coming out your tap, it comes from the reservoir. It's you wouldn't want to drink it as it is in the reservoir. So the flocculants are the polymers or the chemicals that they're adding to sort of take all the dissolved organic matter, which is the technical and polite term of what the fish are doing in the water. It takes and binds all that and removes it. So I was working with on a PhD with this company. So they had a specific end goal, but I had a lot of free time to do my own independent fundamental research alongside it. So that kind of set me down this path. I ended up then postdocing again at the University of Sheffield and then moved to the University of Bradford. My postdocs were clinically based projects where I was sort of the lead chemist. We were developing new sensors. These were made of synthetic polymers, but we were making sensors for microbial infection. So I was working very closely with a biologist and very closely with a clinical partner. So now I'm more of an independent researcher. That kind of ethos stuck with me. I work really closely with local companies. My goal is just to help them understand what quite a lot of companies, we all use plastics for all sorts of everyday life. But if we can better understand what they are, what the material properties of them are, we'll get so much more use out of them. So I do the industrial side of things alongside building my very fundamental, what is the material science, the materials we're handling. And I still collaborate very closely with Professor Rimmer, who was leading the infection sensor work for over a decade. And we're hoping that will be useful for society going forwards.
Yeah, that makes sense. That's quite an interesting journey you've had, and very happy to hear the sentence you started your answer with, that accidentally, but you're loving every bit of it. That's wonderful. Um, So it sounds like you did quite a lot. You did work on quite a lot of different projects. If you could tell us where does your current research, so what you're doing right now, I guess you're working on a bunch of research projects at the moment. So your current research project, where do they fit in this big puzzle of materials or nanoscience? Where do you see yourself?
Uh, so originally I was a chemist. My training is in chemistry, but I definitely, I've, it's very interdisciplinary. I've specialized in a lot of physical characterization techniques, but I work with a lot of biologists. So I see my role as the guy who actually understands what the polymer material is.
Mm-hmm.
We've got a brand new project in the north of England rolling out diffusion NMR studies to the wider community, and trying to offer this to local businesses to help them understand. We all handle these materials, but we can have a better understanding of how they're working and what they actually are. It's really taking all this applied stuff and trying to wind it back to first principles of chemistry and physics.
Okay. Okay, that's interesting. So it sounds to me that you do quite a lot of interesting projects. If you have to pick one or a few research projects or experiments or quirky, fun ones, if you have to pick one or two, could you pick them and explain it to us in super simple words in the section we call in other words?
Okay. Yeah, it's tough to pick one, so I'm going to go with two.
Yeah.
The first one is, and I'm hoping that a lot of other people who are researchers who might listen to this sympathize, but most of us have that paper, that thing, that thing they did maybe 5 or 6 years ago, and they loved it at the time. They did it thinking this is big, this is the one that'll make my name, but for whatever reason it didn't work out. Maybe it all worked fine, but getting it publishing, you could never find the right journal. You could never find the right way to start it. That for me, that paper was written back in 2012.
Mhm.
I remember 2 years later already being frustrated, meeting one of my collaborators and my PI. I was at a conference in India, in
Mhm.
Calcutta, and we sat down and went, "Oh, this is ridiculous. So it's been 2 years. I'm fed up. We just need to get it out there." And we mapped out exactly what the paper would be, page by page, diagram by diagram. Yeah. So what was that? That would have, yeah. And for me, that paper finally came out in 2019. So even after 7 or 8 years, it's no. But for me, that paper was developing a test that could sense specific bacteria, so it could distinguish between Staph aureus and E. coli. So different modes of infection. There's so many biological variants, but we could take a strain that we were looking for, add our material to it, and within 5 minutes of adding our agent, get a disclosive response that told us, one, if it's there, and how quantify how much there is. So an infection diagnostic, if you imagine it, so hopefully in a couple of years' time, this might end up as a device that we can roll out to pharmacists or hospitals. If at the moment, if you go and you have an infection, the gold standard, and it will remain the gold standard, but the gold standard is they swab you, they send the sample off to the lab, and you will find out the next 24 hours, 48 hours later, what it was that you're suffering from.
Mhm.
If we can bring that down to 1 or 2 hours, or even half an hour, just think how much cleaner and healthier, hospitals and care settings will become, because we'll be able to work out that the doctors and clinicians will be able to work out what the problem is, or at least have an idea, and then prescribe treatment on, with a diagnosis almost immediately, rather
Mhm.
than having to sort of empirically guess, oh, I think it's probably this.
Mhm.
So it took us 8 years, 8 or 9 years to publish that, and the reason it got stuck is um, the work was so far ahead of ourselves that we knew that, okay, if we publish this, the first thing the reviewer will say is, well, what about this? What about that? You haven't considered this. And we knew we had, but we hadn't got those tests to a state where we could publish the data. So we had to wait for 4 completely separate things that were happening within our group to get out the way before we could do the thing, like the big headline, the thing that I knew we were working towards. It was material scientists. It's so easy to get distracted. We had to get distracted and solve these other problems first. So
Right.
for me, that's the one I'm proud of. Just quickly, the second one, I'm really proud of as I said, I do a lot of industrial work, but I always try and take it back to first, scientific principles. Just because I'm applied doesn't mean I can't be fundamental. And I did some stuff on polyacrylic acid. Now, this is the stuff you'll find in nappies. It's the main absorbent material. We've been using polyacrylic acid for over half a century, but we found completely by chance some brand new material science information about the way the materials behaves when it's between 200 and 300 repeat units long. It was a completely, and I'd say an example of unintended discovery. You're doing one thing and you say, oh, that's a weird result. What's going on there? And it's opened up a completely new avenue of discovery that we weren't expecting.
That's really interesting, especially the first one. The turnaround time would be amazing if that really comes into the market. This will be amazing. Yeah, also the second one is also quite interesting. So I can understand why you chose two instead of just one research related experience to explain. Wonderful. So I guess you teach a lot. So if you have to pick a few courses or all of the courses that you teach, could you tell us, please?
Okay, so at the University of Bradford, yeah, my role's kind of 1/3 research, 1/3 teaching, 1/3 admin. But
Okay.
the third admin and teaching, a large part of this, for about 2.5 years now, we've been running a chemistry BSc apprenticeship. So we're offering for companies who want to hire new staff on an option to get the full BSc degree, but distance learning. So we do 90% of the course online. Now, up until last few weeks, that's sounded like such a revolutionary thing, but the world's changing with the coronavirus. So I'm in quite heavy demand internally in the university right now. But the positive thing I can say to anyone listening around the world is distance delivery of scientific topics is absolutely doable. But when I am on campus, I also teach the first year undergraduate students practical chemistry, because I really believe in teaching people the lab skills at an early stage. And because it's endemic throughout their studies, undergraduate learning's a process where you're developing people up to the point where they could go on to do their own independent research. So I teach the practical chemistry at the early stages, and then at the master's level, we've got a module on materials characterization, which I do with 2 other lecturers. My focus is looking at, typically it's looking at polymer characterization, but also dynamic light scattering and other characterization techniques. And I also do a module with another lecturer on imaging and sort of the history of imaging and then its applications in science and medicine.
Okay, you teach quite a lot. About this chemistry BSc apprenticeship, is it for everyone all over the world that they can sign up for the program, or is it like specific individuals who have enrolled at the university?
Well, this is going to be an interesting conversation going forward. So the UK has got a very specific national apprenticeship scheme
Okay.
where companies can, sort of pay in to get the certificate, and with our scheme, they get the degree alongside it. But there's no reason if anyone, so it's not 100% at distance. The requirement is because chemistry is a practical subject, they come in for 2 weeks. For 2
Okay.
weeks, once a year, we do as much of the lab classes as we can. But then the idea is that they go back and they're working in an industry, ideally a chemical industry, but and we're saying, okay, so we do as much lab skills as we can in the 2 weeks, and then when you're back at your company, when you're working, well, that is learning. When you're working for a company in the chemical or scientific industry, you will be learning by doing. So we try and wrap as much as what they do on site for their employer into the qualification as we can. So yeah, if anyone has an employer who would be willing to give them day release, it could be rolled out internationally. There's no reason. The reason we adopted this model is chemistry apprenticeships, and not just in the UK. I know in other countries, historically there's been a lot of, there's been a proud tradition of people studying chemistry part-time, but most universities that offer it is because they've got one big, maybe a AstraZeneca or a BASF, or a big local employer which is on the doorsteps of the university. So they'll do day release, but the students still have to come in. They have to timetable all of the lectures on the day that the company gives them off. We've looked at that model and we've said, well, there's no reason it couldn't be rolled out online.
Okay, that's interesting. It will be very interesting for the future and see how it develops. Will be I would be curious to keep an eye out on this. Thomas, I hope that your research experience so far has been wonderful and will continue to do so. However, if you had 3 wishes to improve your research experience, what would you ask for? And I'm not promising anything here.
Well, one thing that maybe this week might help with me, I do quite a bit of outreach work. I go to some schools and colleges to try and encourage people. And I don't go in and say do chemistry, but I do go in and say do a STEM subject. Well, there's so much you can get out of it. I'm biased, of course. I'm biased, but I really want a clear view from the wider community. When I'm talking to the general public, when I'm talking to students, when I'm talking to college students who are thinking about university in the next couple of years, do I need to explain what a polymer is every time I introduce the concept? I mean, we all say we know what plastic is. It's a common term, but I'm biased. I'm an expert in the topic. I'm kind of stuck in the looking glass. I'd like someone in the wider community to say, yes, polymer is a term in general uses. The majority of the population has a handle on it, or do I need to bring myself back to first principles every time I want to explain anything? That's something I really struggle with, and I know I'm not the only one. I mean, that's a little thing that I think we could start to work towards an answer on. Number two, the scientific community. I love going to conferences and talking to other researchers, and I think there's so much great stuff in material science out there, which I love. But I do love that. I'm afraid, sad to say, the stuff that really excites me is when I see a researcher turn to a really bizarre characterization technique. In our fields, we all have the standard, this is the microscopy used, this is the thermal analysis, this is what we do for this type of material. Fully characterizing materials beyond what you need to do it's very expensive and it's difficult, but we're learning new things all the time, and I get really excited when I see people try their hand at something new. On the other hand, trying your hand at something new can delay you doing the thing you can do, so it's a trade-off, I recognize. Third wish, okay, going to be specific to myself here. As you said, the infection sensors we've been working on, and the stuff I've been doing with Professor Rimmer, I think that does have a lot of potential in the wider community. I kind of wish we'd already shown that it could be worked for fungi and viruses already. All of our stuff has been so focused on bacteria, and then in the current pandemic, I'm kind of don't want to stand up and shout, "Don't forget about bacteria," but at the same time, don't forget about bacteria. You're not just washing your hands because of coronavirus. When this goes away, hopefully we'll all have learned something. And we've been working on this for years, and so getting clinical data is so slow and expensive. But I've been excited about this collaboration, and I really hope I get to see it or something like it in the market, because I think it can really help the wider community.
That makes sense. All 3 fair wishes, and I wish I could grant them, especially the third one, with the clinical trials and the trials. The first, you have to do the trial in the lab, then there's the clinical trial, and there are so many steps. I hope, again, echoing what you said, don't forget about the bacteria. We also have other tiny things living at the nano or micro scale, and not just the coronavirus or COVID-19. Um, Wonderful. Thank you for sharing your wishes. Let's talk a bit about the future. What are you most looking forward to in the next 3 months, except going back to the lab, I guess, with the times like today?
Well, I mean, going to lab's going to be interesting. We were supposed to be moving into a brand new laboratory at the end of March. We've
Oh.
had new fume hoods, a glove box, larger offices. All the PhD students and postdocs we work with will hopefully get a better space to work. But and we'd now be located in the same building as our analytical equipment, whereas before it's take the elevator down, cross the road, go up the flight of stairs. So yeah, okay. So, I mean, I'm looking forward to spending a lot more time with my children. Although explaining to them that Daddy's working is going to be quite an interesting experience. But the next month, there's no reason this lab shutdown means the next month is not going to be productive. I've got a backlog of collaborative papers and personal papers and research grants to sign off, and getting through this backlog is not going to be a problem. Maybe it depends how long we're here for, but hopefully this will give us a chance to recharge our batteries. Time to think. And when we do go back, I'll be reinvigorated and ready to go. And hopefully this shutdown isn't going to drag on the entire year. That's a larger conversation, but assuming life does return to normal, and it will eventually, I'm involved in 2 UK conferences, recent appointees in materials science and recent appointees in polymer science, RAPS and RAMS. These conferences are for postdocs and recently appointed primary investigators, both in academia and industry. And I've been to them for the last few years, and they're fantastic sort of conferences to network. So I'm looking forward to networking online, but I'm hoping we do get to meet face to face before the end of the year. Hope for some sort of normality eventually.
Yeah, let's hope for that. Let's hope the normalcy comes as soon as possible. It's been like 2 weeks of almost 2 weeks of home office again. It's already getting on people's nerve. I see it on Twitter, especially with people with kids at home. With the schools closed and the kindergartens closed, it's quite challenging.
Yeah.
Speaking of which, before we let you go, what we want to understand from you is what are the big challenges or questions faced by the field of nano or material science that the researchers are working towards answering?
It's characterization. I mean, there's so many sub things from that. Every researcher will have a specific question that's driving them. But if we really, it's always characterization. We're getting better all the time. People are developing new techniques. Our ability to understand what's happening at this nanoscale. With every new technique that comes along, our understanding gets better. So we've come so far, but it's, as I've mentioned before, it's tempting to stick with a few standard analytical techniques. But if you go beyond that, it's expensive. If you do stuff that is unnecessary, that's a waste of research time, which is precious, and it's also a waste of research equipment, which is expensive to maintain. But if we don't fully disclose our material properties, we won't get the best use out of the things we're producing. So balancing time pressures, limited budgets against the potential for discovery. I know it's something every researcher battles with. So this is a very glib answer, but it's characterization. It's for material science, it's always going to be characterization.
That's fair, and that's quite an interesting take. That's quite an interesting challenge. I never thought about it this way. As a material scientist myself, I never thought that characterization could be a challenge. But you're right, coming up with innovative and interesting characterization techniques, which are not expensive always,
would be really something which will be very useful. So thank you very much, Thomas, for speaking with us, and hopefully you're having fun on the Real Scientist Nano Twitter account.
Oh yeah, no, looking forward to it.
Thank you for listening. To know more about us, please visit our website realscientistsnano.org and follow us on Twitter at realsci_nano.